Hello friends. Welcome to my YouTube channel. In this session, we will continue our Telangana State Transco 2015 Assistant Engineer Electrical Solutions. Now, the question on the screen is: the skin effect in conductors is due to non-uniform distribution of current in it, and a major portion of the current is near dash of the conductor. So, skin effect. Suppose take if a conductor is there, the skin effect is causes the current to be passing major portion is at the surface of the conductor. So this is because of the magnetic flux linkage inside the conductor. So the option is surface of the conductor. So here inside the conductor there is no current passing here. This portion current is not passing. The next question that we have is: in a lead acid battery, the density of acid indicates the charging of the battery. So this is a direct and straightforward question. Next one. So next question we have is: the breaking capacity of a circuit breaker is usually expressed in MVA. The breaking capacity and making capacity are also expressed in same MVA only. Next one. That is dash is used for heating non-conducting materials. So in eddy currents are passing through conducting body such as metals, and arc heating also possible with metals only, and insulation induction heating also possible with metals, and dielectric heating is only possible for non-conducting materials. So in this type of dielectric heating, we will take the capacitance like this. We will operate the body to be heated in this between these two plates, and we will apply a high frequency supply so that the frequency will of this frequency it will polarize the dielectric material inside this plastic or non-conducting material so that it will be heated here. Okay, and the next question on the screen is: so spot welding is used for the measurement spot welding is used for thin metals. For arc welding, the current range is usually as a higher order only, so it is order of 100 to 350 amps. Next one. According to Roth-Harvich stability criteria, for a system to be stable, which of the following options are correct? So if you are drawing the RH criteria, so all the poles should be lie on the left half of S plane only. So poles means poles and zeros should be lie on the left half of S plane only. So the option is roots are in the left half of S plane and not imaginary axis. So this is the wrong answer. The option is the roots on the left half of S plane here. This is the correct answer. So we'll move to the next question. If the gain margin of the open loop system is doubled, gain of the open loop system is doubled, the gain margin is. So gain margin is nothing but it is a reciprocal of magnitude of gain here. So what we are doing here is the gain of the open loop system is doubled. So this is nothing but, so gain margin GM is nothing but it is doubled. So 2 into G now. What about the gain margin? It is become half. Because it is increasing by 2 times means it is increasing by 2 times half here. And next one, phase margin is the amount of angle to make the system unstable here. Okay, when you are going for steady state analysis or stability analysis of control system, so we will draw a margin line. So here we have the system is stable, here the system is unstable. So this margin indicates the phase margin is a margin that indicates if you are crossing this margin, the system enters into unstable region. Next one, the voltage gain of common source JFET amplifier depends upon, the first one is dynamic drain resistance and dynamic drain resistance and drain load resistance. So these two are the correct options. So you can write this one or this one. So both are correct only. The formula in voltage gain AV is equal to, so V0 by Vi, that is equal to conductance Gm into dynamic resistance Rd divided by, so 1 plus Gm into Rs source resistance plus Rd plus Rs divided by drain load resistance Rd here. So from this we can conclude that the voltage gain of the common source JFET amplifier depends upon the dynamic drain resistance and dynamic load resistance. So thank you friends, have a nice day.